Hello and welcome to this video in the measurement series, this one all about capacity. So capacity and volume are two very similar ideas in that it's all about how much space is being taken up, whereas however volume is all about the amount of space a shape takes up, or in sort of uses, I guess. So it's all about the how much space a shape is using, that's volume. However, for capacity, it's how much can that shape take in. So how much can you put in to that shape? Okay, so there's a little bit of difference between capacity and volume. Volume is more often than not just about your different measurement units such as centimeters, meters, kilometers, those types of things. Capacity, we're now moving into milliliters, liters, kiloliters. Okay, so we're trying to use slightly different terminology for these bits and pieces. Now on your screen there you can see a table that has some of the different conversions that are going to be useful for you in terms of working out capacity from volume. So we often take the volume of a shape and do some converting and we'll find out the capacity. Let's have a quick look at some examples. Here's our first example. We have a container that is filled with water. Okay, the volume of the container in cubic centimeters is the first thing that we need to find, and then using that to find the capacity. So let's do A, find the volume of the container. So we have volume equals the area of one of the faces times the height. In terms of this one, this is going to be the LBH, or it could be length, breadth, width, or base, height, depth. However you wish to put it, I'm going to just use length, breadth, height. So it's just all three of these numbers multiplied together. So it's just 70 times 40 times 30. So just those three numbers all multiplied together. Okay, now we whack that into a calculator, which you probably shouldn't need to do at this point because it's really just 3 times 4, which is 12, times that by 7, which is 84, and then add your 3 zeros at the end. So there's some mental strategies that we can be using here as well. We need to get to 84,000 centimeters cubed because we want, as we said before, cubic centimeters, because again we're looking at volume and using volume to get us across to capacity. For B is the big one here for our problems today for capacity. So we want to know what the capacity of this container is in liters. All right, so this one's a liters question. So what we're going to do is we're going to say, well, I want to find capacity. And sometimes it is easier just to write that word out. It starts with a C. We use C for all manner of different things. So maybe just writing out the word at this point is pretty good. We want to have that 84,000 centimeters cubed. And we need to multiply it by a number. Now, let's go back up to our table. And we can see here in terms of capacity, we have some things to have a look at. In terms of centimeters cubed, here's our centimeters cubed in the middle. So we know that 1 centimeter cubed is a milliliter. 1 centimeter cubed is 0.01 liters. So 100 or 1,000 rather, 1,000 centimeters cubed is a liter. Now, the easiest way for us to do this one is to use this top version, simply because all we have to do is divide or multiply by 1,000, or divide by 1,000 rather, in terms of getting where we need to be. Sorry about that, dividing by 1,000. So we're going to multiply this by 1 milliliter. Let's write the right M. So little m, big L, little m, big L. If we wanted a big M, we'd be looking at megaliters and not milliliters. So because it's multiplied by 1, it is still just 84,000. That's milliliters for this one. Milli being that prefix for thousandths means that we're going to divide by 1,000. So we're going to end up with 84 litres. Okie dokie. So there we have the 84 litres. We have another example to have a bit of a play around with. Here we have a cylinder. It's a cylinder. We want, again, centimetres cubed, but now we want to go to kiloliters. So we're going to have to divide by 1,000 again to get our answer. Okay, so we're going to find how many kiloliters are in this particular question. Okay, so A, we want the volume first. So V equals AH. Now, we have our circle for our face, so we're going to have pi r squared h. So it's going to be pi times the radius. Now, we have a diameter. We have a diameter, therefore we need to halve it to get our radius. 128 divided by 2 to get our radius is going to be 64. So our radius is 64. We need to square that, then multiply it all by 241. Gets us our answer for this one. So we have pi. This is what we're plugging into our calculator, 64 squared, and multiplied all by 241. We're going to get 3101179.206. Now, this is asking us to do this to the nearest centimetre cubed. That means nearest whole number. So let's find where the whole number stops. That's right over the decimal point. Look at the next number. This one's in the 4 or below category, so it can all just stay the same. So 3101179 centimetres cubed is our approximation. So what we're being asked to do is find kiloliters. Okay, we want kiloliters. So we're going to do the same thing that we did up here for this question. Alright, and we're going to go through that process. So for B, we want capacity. Alright, so now we're going to have 3101179. That's 3,101,179. And that's going to be what? Multiplied by 1 milliliter. 1 milliliter. Alright, so it's going to stay the same because it's just multiplied by 1. So this is how many milliliters we have. Okay, so if we divide by 1,000, we're going to get to our litres. Right, so dividing that by 1,000, we're going to get 3101.179. Now all you really need to do there is move the decimal point. Okay, so now we have litres, but we want kiloliters, don't we? We want kiloliters, so we need to divide by 1,000 one more time because kiloliters are the thousands. So milli being thousandths, make sure it's thousandths, and then kilo being 1,000. So now we divide that by 1,000 again, just moving that decimal point, 3.101179 kiloliters. But again, we're asked to one decimal place it. So let's go to that 1 decimal place. We can see there that the next number in the lot is the 0. That is in the 4 or below category. So approximation, or approximately equal to, we're going to have 3.1 kiloliters. 3.1 kiloliters. Okay, so hopefully this has given you some insight into working with those formulas and capacity and how to do these particular problems. And we'll catch you in the next video.